I do want to show you one other thing, because I just saw Jackson doing this, and this is a good thing to learn about, right? So first off, 0.921, right, times 100. We're trying to get it out of 100. There we go. Let's say you have a ton of lines there, and you want to clear it out because you're anal about that. You don't want all those numbers there. That's fine. I get it. Instead of hitting delete and going all the way through, hit the menu button for me on that calculator. And so I'm trying to do a thing. I'm not trying to do any operations or anything like that. So what do you think I would go to just do a thing that doesn't have to do with math on this calculator? Actions. Check out actions. What do you see there that might allow you to, I don't know, get rid of everything that's there? Clear your history. You clear the history and it quickly gets rid of everything. That's an easier way to do it, right? So this is another way to use these calculators. We will consistently be using the calculators throughout the entire semester because this is hands down the best calculator for, well, one, for learning, but two, for the ACT. So if you learn how to use this calculator well, that can greatly improve your skills on the math portion of the ACT. Okay? So, any questions about converting from area to a percent before we move on? You seem pretty comfortable. Okay, so let's actually learn today about how to get those z-scores and how to get that area and that percent from the z-scores. That's where we're going to pick up. By the way, if you see me start limping around or struggling today, we just had a stupid number of deadlifts at workouts this morning at 225 pounds, which isn't that heavy, but when you do 40 of them along with other stuff, it gets you. Alright, so agenda. We're going to finish up lesson 3, z-scores and percentiles. This lesson 4 is going to be our last lesson and it's pretty short. So as I told you, when am I probably wrapping up new content? Tuesday at the latest, possibly on Monday. So if we finish up on Monday, be thinking that we might have a test on Wednesday. Anthony, buddy, come on, man. Thank you. So we might have a test on Wednesday. At the absolute latest, our test will be on Thursday because we have to get into the traditional algebra side of things and getting out of the statistics. We'll review statistics here and there throughout, but that's something we want to be aware of. And so that lesson 4 will be the last lesson. Now, the test is not the only assessment we'll have next week. What else will we have? Understanding check on Monday. Okay, so remember, just like last time, I legitimately need to have a check on your understanding. The whole point of that is you need to know where you're messing up and where you can improve before that test. Because the understanding check is not your final grade on that material. It's just a check. You do better on the test, you learn from your mistakes, you grow and get better, you are going to be golden in my class, right? You don't have to learn it all at the very beginning. You grow and you get better. So don't forget, math and learning is a process. It doesn't happen overnight. It takes time. I would take some time to study, things like that over the weekend. Okay, from there, objectives. I can calculate and interpret a z-score. We started talking about it a little bit yesterday. Does anyone remember what we mean by a z-score? So it can be between standard deviations, but I will say, like, you can have a z-score of 1 and a z-score of 2 and a z-score of -2. So what do we mean by a z-score? If you don't know this answer, then we need to learn this very clearly. Anybody know?
Is it the number of standard deviations away from value?
Number of standard deviations from the
From the
mean. Okay, so if you have a z-score of 1, you are looking at 1 standard deviation from the mean. If you look at a z-score of 2.25, like in the bell ringer, you're looking at 2.25 what? Standard deviations away from the mean. Now I got to ask, do you think it's above or below?
It could be either way.
It'd be negative if it's below. Okay, so notice this ties in exactly to what we've been studying, except the empirical rule can only work with integer values, right? 1, 2, and 3, whereas the z-scores will work with even quarters of a standard deviation and even less than that. So We're going to get into z-scores calculating probability of events or the percentile of a value. And we're going to use percentiles to calculate the value of a data value, piece of data, that one. Woo, words guys, they're important. So moving on from there, we did this yesterday, the getting started. Again, this was tying into the empirical rule. Don't forget, what are the percentages for that empirical rule? 68, 95, 99.7, right? You got to know those three so that you can easily move around whenever you're looking at those integer values, but z-scores are for when you can't do that. Now remember, we looked at this example with Demetrius, right? He tried to just half that 34 because he was half the standard deviation above. Can you just half that 34% though? No, why not?
Because it's not symmetrical.
Right, so remember it's symmetrical around the mean, but if I'm looking between 0 and 1 standard deviations, isn't that more area than this unshaded part? Right, so when you're only looking to one side of the mean, it's no longer symmetrical. It's symmetrical about the mean, but not to one side of that mean. So that's why we need these ideas of z-scores. Okay, so I think we started to hit on this a little bit yesterday, and is this part right here above the worked example in the book? Yes, okay. So here's what I want to show you, and I think I started to touch on this yesterday. If I am looking at that, I think the mean was 54, is that right? One standard deviation was 6, so it was 60. But we were looking at 57 and below, right? Boom. So we already said that 57 is 0.5 standard deviations, and now we recognize above the mean. Well, we're trying to figure out how many standard deviations it is above the mean. So how do I figure out just the deviation from the mean? How do I figure out that 57's deviation from the mean? Well, this z-score is the number of standard deviations. Listen to the question again. We've talked about deviation in the past. How do I find the deviation from the mean? Let me ask it a different way. How far is 57 from the mean? Okay, so how are we getting that 3? Subtracting. Remember, a deviation is a difference between. So 57 minus 54. That's a deviation. But that's 3, right? But we know that it's only half a standard deviation. So what do I need to do to this to get to that 1/2? And remember, how much was the standard deviation? We did some kind of dividing because what is 1 standard deviation? How many units? 6 miles per gallon. What can I do to 3 with a 6 to get 1/2? Divide. And so what we want to recognize is to calculate the number of standard deviations. That's just the value that we're looking at, 57, right? So value minus, what's that 54 again? That's the mean, which, so, well, I was going to write 2 different formulas. Hold on 1 second. Remember, if it's a population value, it's a mu, right? Divided by the 6, but what is that 6 representing? Standard deviation, so sigma. Or, if you only have a sample, what's the statistic instead of mu? It would be x bar. And what's the statistic for sigma? S. That's it, right? To find the number of standard deviations, all we're doing is we're just taking the value that we have, we're subtracting the mean from it, and dividing by how big a standard deviation is. That's how we figure out how many standard deviations we're looking at. And that's what your z-score is. Okay, what are your questions? By the way, this is page 36 or 36. Yep. We're still on page 36. Okay.
Where'd you get where'd you get 6 from?
It's in the. Is that like it's given to us right here? 1 standard deviation is 6 miles per gallon.
Oh, okay.
Right. So remember that was in the getting started. It was in question 1. Yeah. Okay. What are your questions? questions before I continue? Going once.
Well, what you talking about?
I was asked, what are your questions about z-scores before I continue? So remember, if you find how far it is from the mean, you divide it by the number of standard deviations, or divide it by what a standard deviation is. It tells you how many standard deviations you have. So here's the one thing that I want to point out and I need you to be aware of when it comes to the z-score table and how we are reading it. When you do a z-score table, all right, so actually let me go, so this is towards the end of the book. This is an entire z-score table. That's a whole lot, or not end of the book, but it's the end of the lesson. If you want to go ahead and glance there. So I want to point this out about the z-score table because this is important. So you see this z of, I'm going to look at, so that's negative 2.3, that's 0.06. And so when I look together, I'm looking right here. I'm going to come back to that in a second. So that is a z of negative 2.36. Okay? That's a z of negative 2.36. Just looking here. Negative 2.3, that gives me through the tenths. 0.06 gives me the hundredths. Yes, ma'am?
Where did you get the 0.06?
I'm making something up to explain how to use this table.
Okay.
Okay? So good question. So what I want you to be aware of is the way that this table works is that you're looking at a standard normal curve. Okay? I'm just going to estimate, but here's my mean of 0, here's my mean of negative 1, or standard deviation negative 1. There's negative 2, and so negative 2.36 would be here. What this table is always giving you is the area to the left of that z-score. So the area underneath the curve to the left of negative 2.36 is 0.0091. When you read a z-score table, what it's always giving you is the area to the left of that z-score. We're going to have to learn how to use that to even find stuff to the right. Does anyone have an idea of what I could do to get this area to the right if that's what I wanted? Not from 100, not 99.7.
Wouldn't you do 0.009 like times 100?
Not times 100, because remember that's going to give me the percent here, and you're still thinking about a percent. Remember that is not a percent, that is the area. So let's say I want to get the other side of the area, not 100% minus, but
Like 0.997 or something?
not 0.997. Oh yeah, remember the area of the whole curve is 1, which goes with 100%. So if I want to get what's to the right, I would do 1 minus 0.0091. I can then convert that to percentages, but we need to be aware, right, we're only getting areas to the left, so if we want stuff to the right, that's what we would have to do. Okay? And the same thing is true over here. So notice all of these are what kind of z-scores? What do they all have in common? They're negative z-scores. I move over to here and I look at my positive z-scores. And so we're looking now at positive z-scores. What do the areas all have in common for positive z-scores? So look at the areas. What do all those areas have in common?
It seems like they all start with.
Well, no, I'm talking about the areas. I mean, all areas are positive. But there's one thing that we would want to notice about all these areas. They are all greater than something.
They're all greater than the one that's above.
Well, and that's always going to be true, but they're all, notice, are greater than 0.5, right? Because if I take any positive z-score, isn't it always going to be greater than 50% or 0.5? That's what we want to recognize there. Whereas everything that's a negative z-score is less than 0.5, right? Because we're looking at to the left versus the right of that mean. Okay, we're going to get more practice with it, but that's what I want you to be aware of. Right, so if I look right here, and again, I'm just picking something, 1.27, so I'm going to come across, and that's where they intersect. So if I have a z of 1.27, I'm looking at an area of 0.898, that means what is the area to the left of that z-score? So 1.27, what's the area to the left of that? Nope, to the left. Hold on. Everything in the table is already what's to the left. So what's the value in the table, the area? 0.898, so what's the area to the left?
0.8.
Right. Remember, every area in the table is the area to the left of your z-score. Okay? Every area in the table is what's to the left of that z-score.
Is it the opposite if it's negative?
No, that's my point. Every area is what's to the left. So notice, like, when we went right here, negative 2.36 had an area of 0.091. Notice negative 2.36 is right here. See how that's such a small area? Whereas, and that's what my point was, all of these are less than 0.5 for the area, because if it's negative, it's to the left of the mean, and if it's to the left of the mean, it's less than half of the data, right? If it's something that's to the right of the mean, it's got to be something more than 50%, which is what we see in the table. That's my point, is every area in that z-score table is only what's to the left. So we're going to have to play around with it to get what's to the right or what's between things. And we'll talk more about that, but that's the background for that z-score table. Questions before we continue? And I will say we'll get more practice with it. I'll re-explain it as we go through, but what are your questions before we continue from here? Oh, I need to go backwards. Okay, so we are on this question 2 right here. So what would a negative z-score indicate? And now we have to be careful. I need you to hear me very clearly on this. The z-score is associated with an area, but they are two different things. You get the area from the z-score. But pay attention, is this asking for area? No, it's just asking about the negative z-score. You have to be careful with distinguishing those two things. So if you have a negative z-score, which we just looked at an example of that, what is a negative z-score always going to indicate? Well, but go back to what do we mean by a z-score? So remember, z-score itself is the number of standard deviations from the mean, right? So what does a negative z-score tell us?
It's the same thing.
So it is the same thing. I'm going to say, Kai, what were you saying?
It's to the left of the mean.
So the value is to the left of the mean, so it's the number of standard deviations below the mean, right? If it's positive, it's always the number of standard deviations above the mean. Negative means it's the number of standard deviations below the mean. So a negative z-score.
What page we on?
M5-26.
That one.
Don't push.
Guys, I went back to activity, this is, 36. I went back to activity 3.1, I think. Okay, so I'm going to write over here so I can put it up higher, but this is number 2. And if you don't, here we go. Remember and highlight this, a z-score is a number that describes a specific data value's distance from the mean in terms of standard deviation units. That's how we define a z-score. So a negative z-score is the number of standard deviations a value is below the mean. Okay? So a negative z-score is the number of standard deviations below the mean. Okay? So make sure you get that note down somewhere. And so we've started to look at how a z-score can be found, or an area can be found from a table. And what a table is just someone has gone through using calculus to find the area for all of those different z-scores to the hundredths place. That's how that came about. But you know what's way easier and way more fun than a table? Calculators, let me tell you. Good grief. I love calculators. Now I'll go ahead and tell you, you will have to do at least one of each on assessments for me. But then after that, you can use whichever method you want. So I want to see that you can use both methods, but afterwards, you can use whichever method you want. Is that clear? Okay. Now we'll also point this out, because students freak out every time. If you don't remember how to use the table, can you still, on the table one, use the calculator to get some answer?
Yeah.
Does that still show me some level of understanding? You can't earn a 4 or a 4 plus that way, but maybe a 1 or a 1 plus, it's still better than nothing. Right? So show me what you know. Even if you only learn how to use the calculator, there's other methods to do this. Now, I do want to point this out. Right here is a fantastic time where you may want to bring a laptop in to download the software. I have free versions of these TI Nspire calculators that can be downloaded onto any one of your computers. It's free. You don't have to pay for it. You come in, you give it to me. Probably during enrichment, I'll plug it in, download the software, and give you the software key. The software itself is not cheap, but I have it for free from the program I'm doing at UA. So, bring a laptop in, I'll be more than happy to give that to you. Okay, so pick up those calculators. Let's learn how to use the calculators. One of the things that I would probably do is I would take a couple of notes under number 3 about how we're doing this so that you can use this later. So, can you see? Yeah. You want a calculator page, right? So it could be a scratch pad calculator or it could be a document calculator, either one. Any guesses what button I'm going to press to start getting to menu? Yep, I'm going to go to menu. Where are we going to go from there?
Probability?
So we could check statistics or probability. Let's check under statistics right now. All right, what are we studying at this point? We're studying distributions. What type of distributions?
CDF?
Well, just in general, what type of distributions? Normal, right? So go to normal CDF. I'll go ahead and tell you, you will never use normal PDF. You will want normal CDF, right? So here's what I want you to recognize from here before we put anything else in. First off, with a standard normal curve, what's the mean? No, 0. What's the standard deviation? What's already in there? 1, right? This is already set up for the standard normal curve and the standard deviation if you have it in z-scores. Now, here's what we need to pay attention to. All right? We are looking at, I believe, it's the 57 again, right? So half the standard deviation. So z equals 0.5. And we want what's to the left, right? And so it asks for a lower bound. Technically, does this curve ever stop going to the left?
No.
No. So we don't really have a lower bound. And so this is, in the calculator's mind, as close as it can get to negative infinity. Okay? So if it goes for forever, you don't even have to go that far, but if it continues forever to the left, you can type like negative 100 in, or negative 1,000, or whatever. It'll be fine, because realistically, what's the lowest z-score we've looked at on the calculator? Or what is the lowest z-score we've been looking at, for the most part? -3, right? So going -100 is well beyond that, you're fine. Okay, so what is the upper bound of that shaded region that I want to find?
So you want us to put 100, -100?
I mean, you can put -100, you could have left the -9E999, you could put -1000. It just needs to be super negative in compared to that -3. Alright? So what's the upper bound of that shaded region that we're looking at? Guys, I've already given it to you. 0.5.
Oh.
Right? A z-score is based on the standard normal distribution. So the upper bound is 0.5. Hit enter. So what is the area to the left?
I can't tackle K.
It's not open.
Oh.
0.6915. I'm always going to go 4 decimal places with this. Here's why. Let's go back to the table. How many decimal places for the area does that table go? 4 of them, right? The table always goes to 4, so for the calculator's sake, I always go to 4. Actually, I want to show you this. Hey, what was the area that the table gave us? 0.6915. So do the calculator and the table agree? Alright, so we don't have to use the table. If you know how to use that calculator to give you the same answer, personally I think it's easier. The one thing I'm always going to do, just like with the empirical rule, I'm going to draw out my standard normal distribution, estimate where that z-score would be, draw in or shade in the area that I'm looking at. It's going to help you when putting these values into the calculator. Okay? We're going to get some more practice with it, and I'll let you write some notes down in a second. But I do want to point this out about the calculator. I meant to do that earlier. Someone mentioned maybe under probability. Do you see distributions under probability as well?
Yes.
Do you see your normal distribution there? So you can access the normal distribution under both probability and statistics. If I were you, we would definitely want to write here that final operation, norm, was it norm CDF that popped up on the calculator?
Yeah, norm CDF,
And then like
parentheses,
-100 is what we put, 0.5,
0,
0, and 1, right? So lower bound, upper bound, the mean, or so mu or x bar, and that 1 is sigma or s. So lower bound and upper bound refer to the ends of shaded region. Okay. If you need to add any extra notes that you think you might need from the calculator, take this time to do that. Work within your small groups to also complete number 4 about how does your answer using technology compare to your answer using the z-score table. So let's continue writing. Let's start talking about number 4, and we will continue forward in just a minute. Oh yeah, I need to collect the talk the talk. Please get your talk the talk out with your name on it on the same side as the talk the talk.
I have a question.
Yep.
What is zero? What does that say?
Mu or x bar / x bar, because remember it's our mean.
Are they new?
I want anything to worry about.
We're gonna bring the senators back.
Me too. Can I bring it back?
Bring it back
You
in.
gonna be in here, right? You don't have class. I don't want to see it. I decided.
They'll understand us out soon as well. We're so interested.
No, yeah. It was my table, they rounded the board. Still the same. Yeah, no.
Oh, no.
They rounded.
Wait, you play music?
Oh, I know my bad.
You want a high five?
All right, let's start talking about answering 4, and then we're gonna get started in just a minute. I will say if you finish 4, you can move on to 5. $36, $37, what you should be looking at now?
This is not right.
Oh, that's the previous one. As long as you get it
Does it matter that these short tables are rounded to 5?
I would have rounded to 5 as well. I go to 4 decimal places to match the table. Or to match the idea of the table. Thank you, thank you. So how does our answer using technology compare to your answer using the z-score table?
It's none.
It's very close to being the same. Which one do you think is more accurate?
The
The
calculator.
calculator is just a little bit more accurate. That's the only difference. The calculator is just a little bit more accurate because it doesn't have to round as much. I will point out on the table, what's the last digit for the z-score on the table? Is it the tenths? Is it hundredths? Thousandths? Was it again the z-score? What's the last digit? Oh my gosh, y'all. Negative 2.36. We know that's tenths, right? And that's hundredths. The z-score, not the area, the z-score. And see, again, this is where you have to be careful. I'm going to tell you time and time again. Having taught AP Stats, the biggest confusion is people don't pay attention to that language and the distinction. The z-score gives us the area, the probability, but remember the z-score is the number of standard deviations above or below the mean. The z-score in the table goes to the hundredths. Can the calculator go beyond the hundredths? Very much so. Okay? The table can only go to for the area, that would be the 10,000ths. Can the calculator for the area go beyond the 10,000ths? Yes. So again, that calculator is just a little bit more accurate. That's what you want to recognize. Okay? So number 5, Irina calculated the percent of hybrid cars that get less than 56 miles per gallon using a z-score table and technology. Explain why Irina received different results. You'll notice Irina went to a z of 0.33 and she got an area of 0.6293. Now I want to point this out, right? So notice she converted that 56 miles to a z-score, right? So think about how she did that. Z equals 56 minus, I believe the mean is 54 divided by 6, right? Does that sound right? Value minus mean divided by standard deviation to get z. And then, so she is looking at that z-score and to the left, so the area to the left of that. And she gets a value, an area of 0.6293. In the calculator, she got an area of 0.63055. Those are a little different, right? Now, before I want you to talk with each other about why they're different, I do want to point out, she did not use a mean of 0 and a standard deviation of 1. I recommend converting it to a z-score, but notice she literally just used what mu was in the context and what sigma was in the context, and she didn't use a z-score, she used the actual value. That's completely okay. You can do that. I personally recommend converting to those z-scores. Okay? I recommend converting to a z-scores and using the standard normal distribution because it's going to help you understand the z-score more fully. Okay? So that's not a difference, or that's not the issue. I want you all to take just a couple minutes, talk about why this area from the table and this area from the calculator don't match up. And I will point out and tell you it has something to do with the z-score. Take a couple minutes, examine that z-score and see what happened.
Alright.
Something to do with Z-score. Z-score is the.
What is this? Right?
So,
You both of it, 0.5. I don't know how to write it up. Like something.
what?
I don't see.
This is 6 minus 54.
Alright, so what do you do?
She did one of the things.
I'll say, I will tell you this, it's not just about the calculator being more accurate, because that's a significant difference.
Does that
Focus on the z-score, there's something with that.
2 over 6 is
She did something with the actual.
I'll also tell you, it wasn't an issue putting it into the calculator. That's exactly what she got, right? Focus on what I said, it's something to do with the z-score.
Yeah. So that's the difference. She used the wrong one.
The wrong, like.
Didn't use anything wrong.
I tried.
What did I tell you it has to do with? So it's something to do with
I
the
don't want to
z-score.
try, but I'm trying hard enough.
Have y'all looked at that z-score at all?
this thing, right?
Right, but how did she get that 0.33?
So we're trying to figure out why
Like, I
she
tried
did
to understand.
I mean, I already kind of started it for you.
I don't know, but it's 24, but that's 2 over 6.
Yeah, but what did I tell you that I would focus on? Like, I don't know where y'all look more heavily at that z-score at all.
How do you figure out what you got?
She got the z-score right. That's right.
She got 99.
Think about what you just said. That's where the issue is.
Yeah, that's it.
She got
Come up with anything?
it's 0.3
Have y'all looked a little bit more heavily at that z-score? I'll tell you, based on what you put in the calculator, based on what you use in the table, everything's right. There's something with that z-score. Well, there's the area underneath the table, or under the curve, they have the table, but I'm saying something happened when she went from the z-score calculator to the z-score.
They got a different amount of significant figures.
I mean, was the value 56?
Yeah, but it's the same thing. Look, 63.
Was the mean 54?
I'm not at your side.
She knows.
Yeah, I know.
She gets out.
Okay, look.
I just got.
The mean for those cars, the mean gas, or
It's repeated.
the fuel efficiency was 54 miles per gallon, and the standard deviation was 6. She put all that in right.
And then, you
That's
know.
all.
Thank you. Thank you. Okay, so I'll go ahead and tell you, right? This is a tougher thing to just puzzle out, but I have to ask, has anybody figured it out yet? What happened? What went wrong?
Is it because it's 0.3 repeating? Did I just?
What's 0.3 repeating?
The z-score?
This z-score right here is 0.3 repeating.
Yeah.
56 minus 4 is 50, minus 54 is
2.
2. Divided by 6 is 1/3, which is 0.3 repeating. Can you get 0.3 repeating out of that table?
No.
No.
What can the table do? Go to-
You can only go to the tenths or hundreds.
So 2 decimal places, right? Can the calculator get more accurate than just 2 decimal places on the z-score? This is what I was talking about with the idea that the calculator can be more accurate. Okay? And so that was the issue. I will point this out. You don't have to type this in, but I wanted you to see something. Alright, if I go to the calculator again, normal CDF, right, -9E999, upper bound. If I use the standard normal distribution, that's a 1/3, right? That z-score. Notice how I can put 1/3 in there? Is that what we saw when we put it into the calculator? True. But what if I did it as 0.33 instead of 1/3?
Why didn't it
Is that what she got in the table?
Yeah.
That's where the difference comes in, right? If that decimal is repeating, the calculator can handle that, the table cannot. The table can only go to the hundredths in the z-score. That's one of the reasons why I prefer the calculator. And so we would want to note, the table can only go to the hundredths.
What would Randy say?
I would put it next to number 5, or somewhere within number 5, to the hundredths for z-scores. And again, you gotta be careful about z-score versus area. Right now we're talking about the z-score. That table can only go to the hundredths for the z-scores. Okay. At this point, I want you to try number 6 within your small groups, but hold on, before you start, listen to these instructions. And then if you finish number 6 before you come back together, try number 7. But I want you to do this. Every time I try to find the percent of data or the area underneath the curve, and notice we do want to get to percents from that area. Every time I do this, I draw my standard normal distribution. I approximate using my standard deviations where the z-scores are, and I shade in the area that I want. It will help you, especially with a question like number 7. So I find my z-scores, I shade in the areas on the standard normal distribution, and then find those areas. If I were you, I would practice using both the table and the calculator. The z-score and the shading is what takes the most time. Go ahead and use the table and use the calculator to see if you get the same answers. What are your questions? Don't forget, the expectation is that we are checking in with each other, making sure that we understand and help each other grow and learn, okay? Are you trying number 5 right now? Or 6, I mean? For number 5 or 6? Are you looking at 5 or 6? Okay, so what I would do is instead of marking the standard normal distribution that's already been created, I would create my own. 1, that's only a normal distribution, not the standardized one. And 2, I would practice drawing it out because you're not going to be given this normal distribution on assessments. You will have to draw it yourself.
What's the difference between the normal and standardized for
So the standardized normal, remember, is actually the one based on the z-scores. It's the one with a mean of 0 and a standard deviation of 1. If you look at the previous normal distribution, that was the one for a mean of 54 and a standard deviation of 6. So that would be a normal distribution, and what I would do is I would convert it to the standard normal distribution by getting z-scores. So like, so if you're looking at the gas stuff, the mean was 54, right? With a standard deviation of 6. But if I was looking at a standardized normal distribution, it would have a mean of 0 and a standard deviation of 1. Notice how those line up?
Yeah.
So it's taking this normal distribution and converting it to z-scores so that you have a mean of 0 and a standard deviation of 1. But I'm going to draw it. So 1, I'm going to always calculate a z-score,
Yeah.
and then I'm going to create this graph and use my z-scores to find the
So
areas.
the bottom one is
Just a normal distribution,
the top one is normal standard,
standardized normal.
and we're trying to turn the normal one into standard.
Right.
With z-scores.
Right.
And then by doing
The
that,
z-scores are the standardized normal distribution.
and then doing that, you would do like 54 minus 60, then you get 6.
I think it would be 60 minus 54.
Because
Because remember, it's the value minus mean. Because, and that's the issue, right? If you did 54 minus 60, you would get negative 6, and that'd be a negative z. But it's supposed to be, it's above, so it's supposed to be positive. How's it going? Hey, it looks like you're high. What's the whole thing you started off? What's the first thing we learned how to calculate?
Would it be?
He's right there.
Right? What is a z-score? Number of standard deviations above or below the mean. Have you found your z-score yet?
We're trying to say.
Because the area, the percents that you're looking for can come from that table, right? The area is what's on the inside of the table, but what do you need in order to find the correct value from the inside of the table? What's on the outside? Z-scores. To find these areas, you need a z-score. Just one. What's the first thing you
You say,
Yeah.
pretty much like,
Start there. You need a z-score in order to find this area. Now, I would grab, once I get my z-scores, I would create this thing on a curve, and I would show where that z-score is. Alright, get that done.
It's already great, so far.
No, you're not. You didn't show anything on that paper. But here's the thing, is that 50 based on the standard normal distribution? Because the mean of 0 and standard deviation of 1 is based on the standard normal distribution.
So it'd be 70.
No, ma'am.
So
If you want to use the standard normal distribution with a mean of 0 and a standard deviation of 1, what do you need to calculate?
Hey,
Hey, hey, hey.
wait a minute, wait a
No,
minute.
but you. I'm gonna go check on other people do it.
I'm trying to keep it moving.
Do it. It's pretty good. Good.
so 50 miles per gallon.
Why'd you give that 0.5 right there? Yo, what's the mean of the standard? Yeah, the standard normal distribution is the 0, right?
Wait a minute.
So what do you need to calculate? 'Cause I'll say this. I'm glad that we're thinking about that. I usually use that to that level of detail with the empirical rule. But remember, the whole thing is we don't have whole standard deviations anymore. What do you need to calculate at this point? The standard normal curve is based on z-scores. Have you found your z-score yet? Don't look at me like that. It's literally over here. We broke it down. How many questions do you ask them? How many questions?
I mean, I didn't know what questions to ask.
If you didn't understand any of it, then you start at the beginning. Be like, Mr. Kenny, I don't know how you did that. Well, then you should have asked questions earlier. Talk to your group now.
They don't know, they don't.
That's a whole lie. I'll come back and check. Here's the thing. This is once you have the z-score. It is on this page how to calculate that z-score. You have a value, right, of 50. Look over here how to get that z-score. Okay?
Where 50 come from?
I'm going to ask a question, and then I'll get back to it. Thank you, thank you. Okay, so I want to emphasize this because I know that some of us are still struggling. When I let y'all go back, I'm going to start on this right side over here. But what is, if I am given this 50 miles, I want the percent, I want the area under the curve. What's the first thing that I need to calculate if I want to get the area from that z-score table? Oh, I need a z-score, guys. Don't make it more complicated than that. What is the equation for the z-score formula?
that's the problem.
No, it's not the problem. It's in the book. And you wrote it down. It's the value minus the mean divided by... Oh, that's right. Because what we're doing is we're finding how far that value is from the mean, dividing it by the standard deviation to figure out how many standard deviations you have. So calculate your z-score, work with your group, and I will point this out, you probably will not be able to use this table, you will probably have to go to the table in the back, but once again, actually go ahead and tell me, what is that z-score?
I got places.
Okay, so 50 minus, what's the mean?
54. True.
But I did that.
You put it right
I got
at
negative 200.
Man, you
What is
don't
wrong?
know.
What's that problem, sir? Right. Okay, less than 50. It's in the directions. Divided by the standard deviation of 6 gives me negative 0.6 repeating.
That's just the fraction formula.
So that is my z-score right there.
Where 54 come from?
Bro, the Michaels.
Elijah.
I'm not playing with
Elijah, listen. This whole lesson is built on the same context from the beginning, that the hybrid cars get a fuel efficiency of 54 miles per gallon on average with a standard deviation of 6. Go back and look at the previous lessons. So many of y'all are just staring at this problem without going back and looking at the beginning of the lesson. It's all from the same context. That very first paragraph. It's also in the getting started. So, as I said, from here I would draw my standard normal distribution. Here's my mean of 0. I would personally mark the negative 1. Where is negative 0.6 repeating going to be?
Would be kind of like in the, yeah, between.
Right? And not halfway between, a little bit closer to the negative 1, so maybe right here. And so I'm shading all of this. This is the area that I want. Now you need to be careful and remember, what does the table give you? Does it give you that area to the left? Well, we may not be able to get super accurate with it, but my question is, does the z-score table give you the area to the left of that value? That's the only thing that that z-score table gives you. So use your table, find the value in there. You'll need to check again, that's not the right page. Okay, so pay attention. There's 2 different pages for the z-score table. Work with your group members to get number 6 done.
Once we have the
So there's your tenths. It's a 6 again, right? So we need to find where they meet.
this point
Is it right there?
0.6, right?
Continue.
I think it's this one.
Oh
Oh yeah, you're right. Negative 0.2456. Negative 0.6. Right? 0.06. We need where they meet. Right there. That's the area to the left. Use your calculator once you finish with the table.
Well, it's either
Anybody else questions?
Well, on the calculator, we can have some.
Starting to make some sense? I mean, remember, it's the very first time you're looking at this.
It's like a 0.27.
Do you understand this is z-score formula? So that's it, right? 50 minus 54 is negative 4. Negative 4 divided by 6, negative 0.6 repeating. That's it. The whole idea, remember, is that if you look at this equation, the value minus the mean tells you how far that value is from you. But then I need to divide it by the standard deviation, because when I do that, so this is 4 away, divided by 6, it's telling me that it's negative 2/3 of a standard deviation from the mean, from below the mean. And so that's all we're doing. We're trying to calculate how many standard deviations it is above or below the mean.
Upper bound.
Okay? Questions? Okay, collaborate with each other, check in, use that calculator now. If you finish number 6, try number 7. So is that value an area?
put z-score.
So this is why every, this is my
Negative 26.
This is why I don't ever just write out that, I start with z equals. because now I know it's not an area. Now I know, okay, I have a z-score, I need to find the area, so negative 0.6, 0.06, that's what gives me my negative 0.66. I find where they overlap. Right, boom, boom. So what's the area?
That's what I know.
The area, what is this?
That's,
460.
There you go. So there's an area, so now convert it to a percentage.
0.6 right here.
That's all you have to do. Then use a calculator to check it.
Oh, is it 0.06?
I thought it was negative 0.66. Isn't it 0.6 repeating?
No, no, it's not 0.6.
Well, I'm telling you, wait, are you using the calculator or the table?
Oh, we're doing both.
Right, which one, have you already done the
We
table?
did the table, and then we're gonna see what we
So now check the calculator, but when you put it into the calculator, what's the upper limit? It's not negative 0.6.
I just felt like a funny, whatever was there, like 90.
Why? That, right, you do put the z-score, but isn't your z-score negative 0.6 repeating? You don't. Instead, put it in as the fraction, negative 2/3. Just put it in as that fraction. Right, that's why you want to draw it. Don't say, like, as the upper bound, like, that sounds crazy. Look at the graph. Is that negative 2/3 the upper bound? Yes, that's why you want to draw it out every time. That's like, it's not just, hey, I'm drawing it for no reason. There's a reason for drawing it. Yes, ma'am. Have you talked to your group first? So, let me ask you a question. Have you drawn this out? Okay, now have you shaded it? Which direction are you trying to go? Okay, so shade it to the left. Is it ever going to stop going to the left? So what's the lower bound? That's that really super negative 5, right? And what's the upper bound? Where does it stop on the upper side?
He'll be like, which one?
Okay, now we gotta put that.
Well, the upper side would just be what's furthest to the right. What's furthest to the right on that shaded region?
But as soon as he comes down, he's like,
Look at it, you have it labeled. Not negative 0.6, negative 0.6 repeating, right? That's coming from that negative 4.6. So I would type in negative 4 divided by 6. Hit enter.
Why are you talking about that?
What?
I put times on places.
Because right here, minus 54 is negative 4, right? Divided by 6. Remember, the whole thing is that's what z-score. Thank you. Thank you. Thank you. For all y'all getting frustrated, quit doing that. This is literally the first question that y'all looked at trying it on your own. Madison's like, Mr. Kinney, I need you to tell me what to do more. No, Madison, that's not it. I need you to think more and then I'll tell you what to do. Because here's the thing, I need you to remember this. At the end of the day, the thing that I need you to take the most from my class is engaging in the uncomfortable and getting comfortable with it. I need you to get comfortable with exploring and then we'll discuss. There's not a single topic where I have just said, all right, I'm abandoning you. I always bring you back together and we have a whole class discussion about it. Initially, I need you to notice and wonder. Come up with questions. And then we're going to have whole class discussions on it. Then I'm going to release you again to work in your small groups and bring you back in to have whole class discussions. That's the way I operate. Now, quickly, we found our z-scores. What was the area from that z-score? So area, hold on, left of z equals, and we had to do negative 0.66, right? And it was what? 0.2546. Okay. Now, when we go to the calculator, right, we're going to do that norm CDF, right? We're going to go in. But what was the lower bound? And I need y'all to pay attention to this. This is why I want you to draw it. I heard people say, oh, I drew it, but I didn't go back to it. No, quit doing that. This is the area I'm looking for, right? What's the lower bound of that area? Does it really stop?